So this is in response to a student question about sum of products. I'm going to just quickly review that. This is not meant to replace a full discussion, but just kind of a refresher if you kind of understood what was going on, but not fully. Sum just means adding, and product means multiplying. Okay, sum is something plus something plus something. And multiplying is something times something times something, as many of them as you want. Okay? So a sum of products means you're taking a sum of, well, what is it that you're doing? Well, you're making a sum of products. So you take something like this, and you put it there, and you put one over here, maybe you put one over here. Okay, so there you have a sum of products, and then there's blank spots, meaning you put stuff in. You put as many of these addition symbols as you want, as many of these multiplication symbols as you want, but what it means is you're adding up groups, and the groups are multiplied. And so in terms of logic, you can put variables here. You could put like x, y, z, and what we do is we represent logic this way. And we say, for example, x times y bar times z bar, or x times y bar times z, or x times y bar, or x bar times y times z bar, for example. That would be a valid product of sums. Now let's just add to this the fact that multiplication is the implied operation in algebra and in logic if you don't write anything. So the multiplication is implied. So we don't actually need the parentheses. We don't need the addition symbols. So this is all superfluous. We just get rid of this so it looks nicer. All right, and so this is what your sum of products looks like. The other thing to note is that addition in logic is your or, and multiplying is your and. Okay? So if you don't want to think of it as sums of products, you can think of it as ors of ands. And so we can write and, and these parentheses are superfluous here just as much as they were, but because beginning students who are the ones using the ands and the ors are likely to not know about that convention, as a courtesy we usually try to put the parentheses back in to avoid classroom confusion. But again, these parentheses are not necessary. We're just re-emphasizing that the ands are grouped and then they are ORed together. Okay, so this is a sum of products. Why is this useful? What are we doing? Okay, so in your homework, you're supposed to take a truth table, a column in a truth table, and turn it into sum of products. So let me just do that, and then I'll do the reverse of the exercise. So if you have x, y, and z, for example, and this is what your truth table starts out looking like. Oops. And then you're going to go ding, 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 ding. I'm going to purposely do this the cheating way so that you realize that's all we're doing. When we're creating a truth table, we're really just taking, you know, like I have 3 variables, right? If I wanted 4 variables, I could just go like this. Stack it down here, and then the first set would have zeros in front of it, and the second set would have 1s in front of it, and then I would have created a new variable to the left of the one I already have. Okay, but let's say I only have 8 lines in my truth table because I have 3 variables. So just as a reminder, this, if we have 3 variables, we have 2 to the 3rd lines in the truth table, which is 8. We would have 2 to the 8th functions possible. Right? What's 2 to the 8th? Well, 2, 4, 8, 16, 32, 64, 128, 256. So that's how many functions are possible. Okay, so there we go. So what if I just give you one of these functions? Well, I can give you something with some 1s in it and some zeros, and I could say, hey, how did I make that up? Oh, I don't know, I just made it up. That's the whole point. It's one of these 256 functions. I just randomly made it up. And so if I want to express f without using a truth table, I always have the option of doing the following. I have 1, 2, 3, 4, 5 groups of 1s. So I can go ABC plus ABC plus ABC plus ABC plus ABC, and then I can just put the options down as they are reflected in the truth table. So if A is negative, I'm sorry, I called these X, Y, Z. I'm going to change my mind because I already wrote my sum of products down. So if A and B are negative and C is positive, this works. If A and C are negative, are 0, and B is true, then I work. And then if A is no and B and C are yes, then I'm good. If A and C are bad, I'm sorry, A and C are good and B is bad, this works. And if A and B are good and C is bad, then it works. So let me just double check that I got the bars on the right letters. So first of all, I'm just going to highlight them to emphasize what's going on. So I want to know where the, A and B here should match up with the zeros here every time there's 1. So 1, 1, 1, 1, 1. So each group should match up. So I should have 0, 1, 0 over here. 0, 1, 0 is over here. Yep. Then I should have 0, 1, 1 over here. Yep. 0, 1, 1 over there. 1, 0, 1 goes over here. And 1, 1, 0 goes over there. Okay, so this is your sum of products, and if you prefer to write this in a more introductory logic notation, you could say not A and not B and C, or not A and B and not C, or, and C, you get the point, all the way up to A and B and not C. Okay, that is not a simplified way of writing this. This is the most complicated possible way. There are equivalent complicated ways, but that's basically the most complicated way you could write this. But it's correct. And what you do, if you want, you can simplify these. If you want to look up Karnoff, I might be spelling it wrong, Karnoff maps, but they're also abbreviated as K-maps. So if you Google K-maps and logic simplification functions, things like that, you'll find out more about how to simplify logical functions. But the first step is to write it out in its expanded form, and then from there there's tricks you play to simplify it. So even though it may look really awkward and like cumbersome, it's really important to be able to get this step right, because after that point simplifications can be made. I'm going to write a truth table for this existing sum of products. Okay, so I can go 0, 0, 1. You know what, I'm going to just steal from down below. No, I'm not. I don't want to. Okay, there we go. And so this function here, well, when does it turn on? Well, x has to be on, and then y and z is off. So this one is good. Or x is good, y is off, and z is bad. Z is on. So the one in the middle has to be 0. That one works. So this guy goes down here. This guy goes down here. And then what about x has to be bad, y is good? Okay, it's that one. It's that one. Alright, so it's kind of the opposite of the one we just did. All others are going to be 0. Okay, we're using this additive convention because if A is not true, like this first thing is not true, the second thing is not true, and the third thing is not true, if none of these three combinations are true, then the default is off. Okay? Alright. I hope that's helpful. I will just add a little comment that we also have something called product of sums, which we're not going to talk about how to construct, but I just want you to recognize that if instead you have this and this and this, and inside you have something or something or something like that, then you have, I'm sorry, not ors, those have to be anded. I'm sorry. You put ands inside. Alright, sorry, you put or. They have to be the opposite of whatever I did. Ands go between and ors go in here. Yep. This kind of structure, that structure is called product of sums, and it would look like this if you see it written out. And it is mathematically equivalent to what we're doing. It is actually the dual. So we are going to talk in this class about duality. The product of sums is the dual. And this is the only thing I want you to know. You don't have to overanalyze. You just have to know that this idea of sums of products, okay, that these guys are dual concepts to each other, and the fact is we will talk about duality later in the semester. But they are somehow mathematically equivalent, even though from a human perspective, product of sums is nasty and sum of products is easy. But that's because we're humans. It's only a human perception. They're actually of exactly equal difficulty. Okay, I guess that's it for now. I hope I quit.